Welcome back. These are the week 2 notes. This is page 3, even though we're starting at the bottom of page 2. Quick introduction to fractions. So we're talking about section 2.2, equivalent fractions and decimals. We need to start with how we define fractions because we've been trained to be afraid of fractions, and fractions, seeing the patterns in fractions really are useful. So some definition. We got to start by what we're calling the whole. And this is either going to be a single unit or a group. Okay, our whole may be a group of 12 popsicles. We have to keep in mind what our whole is. Our unit amount is what constitutes the whole. Right? Is it 1 foot? Is it 14 bananas? Our reference amount is what we're dividing the whole into. We're dividing the whole by, and I wouldn't focus too much on these. So it's our B, which we see below. Our unit fraction is 1 part. Of 1 over B, right? It's what we're dividing our whole into, B parts. Our fraction, A over B, means we're counting, we've got A parts of size 1 over B. So the denominator tells us the size of the part. Numerator tells us how many. So denominator is the size of the part. It's the bottom of the fraction. Our numerator is how many parts. So it's the top of our fraction. And so here, if we are calling this 1 whole, right, that's our unit. This entire bar is 1 unit. And below, I have it divided into 1, 2, 3, 4, 5, 6, 7, 8. 8 is our reference amount. Each of these pieces is 1/8 of the whole. So this, I got 8 pieces of size 1/8. That gives us our 1 whole. So here I've got 1 piece of size 1/8. Here I've got 1, 2, 3, 4, 5. 5 pieces of size 1/8. And you notice this last one is bigger. If we count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/8. Okay. And if we look at it, we see that we do have 1 whole here, and then I have 1 extra piece of size 1/8. So as we convert from improper fractions where we have a bigger number in the numerator up top, we can convert that to a mixed number and count how many whole parts we also have. Okay, so we're going to use this fraction bar from above where we had 5/8. Think about what would happen if I divided each of these 8s in half. So I'm going to go back up to this one for the reference. So that 8/8 is the same as 16/16, which means down here, if I divide each of my 5 parts into 2, I can now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I get 10 pieces out of 16. So you may notice there's a relationship. If I cut each of those chunks, those are 1/8, into 2 pieces, I end up with 16 pieces total. That's the same as the relationship up here in the numerator. I took the 5 pieces, cut each of them in half, it gave me 10 pieces. So when we talk about equivalent fractions, we are talking about creating another fraction that is the same size, even if we're using different numbers, if we've got different size pieces. So how do we find equivalent fractions here? You notice I have 3 parts out of 4. I'm just missing this top piece up here. So I'm going to look at the relationship between these two. To get from 30 to 5, I've got to divide by 6. So up here, it should be the same relationship. 6 divided by 6 gives me a 1. 6/30 is the same fraction as 1/5. It's going to be the same size, even if we're using different numbers. This middle one, to get from 6 to 18, I am going to multiply by 3, which means I need the same relationship up here. 5 times 3 gives me 15. And the third one, 8 times 11 gives me 88, so I'm going to multiply my numerator by the same thing. 3 times 11 gives me 33. Okay. And this is just a repeat of what I did up above. They have started drilling on my roof, so I was trying to get through this. This is 1 whole. If we cut into 8s, this was 9 parts of size 1/8, also 1 and 1/8.